This is the video for Unit 9, Lesson 1, Pythagorean Theorem.
The goal of today's section is going to be applying the Pythagorean theorem to find a missing side and applying the Pythagorean theorem to classify a triangle as a right triangle. So Pythagorean theorem is typically a topic that maybe you've seen in like 8th grade. And what this says is that if you have a right triangle, we first of all call the two sides that form the right triangle the legs. In this case, we're calling them A and B. The longest side that's opposite the right angle we call the hypotenuse. And so what this theorem says is that if I take the leg squared and I add it to the other leg being squared, that's going to equal the hypotenuse squared. Or a lot of times we learn it as a squared plus b squared equals c squared. So any right triangle is going to have that relationship. So we can use that relationship if we need to find a missing side. So the leg squared plus the leg squared is the hypotenuse squared, or a squared plus b squared equals c squared. In the first example, we have that this is a right triangle, and again, we're going to use that relationship a squared plus b squared equals c squared, or the leg squared plus the leg squared is the hypotenuse squared. So if I look at my right angle, I actually have that two legs are given here. So I'm going to call one of them A and one of them B. The goal of the problem is I want to find my C value or my hypotenuse. So we're going to substitute those values into our relationship or our formula and solve for the hypotenuse. So notice the hypotenuse is always on a side by itself. Sometimes that's what we're solving for, and sometimes it's given to us and we have to do some algebra to solve for a missing leg. So my A, I said, was 5, so I'm going to do 5 squared plus 5 squared is equal to my hypotenuse is x squared. We're then going to simplify. So I'm going to combine like terms. And then once we get x squared equals 50, we do have to take the square root of both sides. But notice we want our answer in simplified radical form. So we're going to be simplifying radicals kind of like we've seen before. So the largest perfect square that goes into 50 is 25. So I'm going to do 25 and times 2. That gives me 50. And then the square root of 25 is 5. So 5 radical 2. I'm not going to use a plus or minus because we're talking about length and we only need a positive for when we talk about length. We can't have a negative length. So the length of the hypotenuse is 5 radical 2, which is roughly about 7.1 if we were to get it as a decimal. The next example is very, very similar. Again, we're going to identify our different sides here. So 7 is across from the right angle. That's my hypotenuse, or my C. The two sides that form the right angle are the legs. So I already have an A, so maybe I'll let this 3 be B. These are my legs. And again, I'm going to substitute it into Pythagorean theorem. So I have here A squared plus 3 squared is equal to 7 squared. A squared plus 9 is equal to 49. We're going to get a squared on a side by itself first, so we have to subtract 9. So a squared is equal to 40. And then we have to take the square root. But again, we want our answer in simplified radical form. So a perfect square that goes into 40 is 4. And 4 times 10 gives us 40. And so our answer would be 2 radical 10. And so our length of our leg is 2 radical 10, which is kind of a little bit bigger than 6, which makes sense then. It's not quite, it's not the longest side because 7 would be the longest side. The second topic is using the converse of the Pythagorean theorem. So what this says is if a triangle has three sides that satisfies Pythagorean theorem, that's enough information to say it's a right triangle. So this is where you're going to be given three sides and you have to determine if it's a right triangle. And we always say that C is our longest side. So regardless of what three sides they give us, the longest side length is always going to be C, and we're always comparing the square of the two smaller lengths to the square of the longest side. In these examples, we're going to be using Pythagorean theorem to determine if three sides given form a right triangle. So again, we're using our Pythagorean theorem, a squared plus b squared equals c squared, where c is our hypotenuse. So when we're testing these problems, we're always making c our longest side, and we're going to verify that the three sides form a right triangle. So in the first example, we have the sides 30, 24, and 18. So these are three sides that do form a triangle. And so we want to specifically see if they form a right triangle. So in order to test that, we're going to take our longest side, which happens to be 30. That's going to be our C value. I'm going to let the other two be just A and B, or B and A. It doesn't matter. And we're going to substitute these into Pythagorean theorem. And we're going to test to see if a squared plus b squared equals c squared. So I have here 24 squared plus 18 squared equals 30 squared. And we're going to see if that equals 30 squared. 24 squared is 576. 18 squared is 324. 30 squared is 900. When I add up 576 and 324, I also get 900. And so notice that there's no variables in my answer. These are just two values I'm comparing. I have that this is a true statement. So 900 does equal 900. So our answer would be yes, the sides form a right triangle. I'm going to put right triangle. For example 2, same exact thing. So my longest side here is C, which is 28. I have A and B. And again, I'm going to put them into Pythagorean theorem. So my longest side is always on a side by itself. And I'm comparing it to the two shorter sides being squared. So 11 squared is 121. 19 squared is 361. And I'm comparing that to 28 squared, which is 784. When I go ahead and add those, I get 482. Compared to 784, they're not equal. It actually would have been this is not going to be a right triangle. If you want to get specific, it ends up being an obtuse triangle. So since we got a false statement, the answer would be no, the sides do not form a right triangle. And that would be it.
If you have any questions, you can ask in class, sign up for T-Will time, or go to the center.